Hello, geometry students. Mr. Zacek here, your math guide to learning. And we are in Unit 2. We're calling this Lesson 3B. Okay, so just as you're following along in your unit outline, this is Lesson 3B. And it's a continuation of what we started before. So we're talking about proving things, and we're kind of building this up as we've been mentioning. I'm going to read what we have here. A proof is a convincing argument that uses deductive reasoning. A proof logically shows why a conjecture is true. And a two-column proof lists each statement on the left and the justification or the reason for each statement on the right. So it logically shows why a conjecture is true. A two-column proof lists each statement on the left, the justification or the reason on the right. So this is not in your note packet, but I wanted to show you a just kind of what law we're using when we do these proofs. If you study logic, it's called the law of detachment. So here's an example. If it rains, then we watch a movie. Okay, so if it rains, the part after the this is called our hypothesis, and the part after the then is called the conclusion. So the hypothesis is it rains, the conclusion. So if we know that this is true, and then here's what we know is true: on Friday it rains, so therefore we can make this determination, therefore we watch a movie on Friday. That's called the law of detachment. When you have an if-then and we know a specific example of the hypothesis is true, the conclusion is true. And it makes sense in that case. Let me give you an example of this with something we've done with one of our proof parts here. Okay, here's a picture, and let's say our statement is AB, lines AB and CD intersect at E, and we know that because it's given. We can make a conclusion that angle AEC is congruent to angle DE. I wrote the wrong letter there. That should be angle DEB. Okay, I've marked those up here. And the reason is, if two lines intersect, then they form congruent vertical angles. The part that I wanted to point out to you is that this hypothesis is always connected back to a previous statement if two lines intersect, and we said that back here. And then the conclusion, we always see a connection between the statement and the conclusion. So angle AEC is congruent to angle DEB, form congruent vertical angles. So the last part of this is that with a proof, that our statements are always going to be specific to the question, meaning the letters, the numbers, about whatever particular problem we're working on, but the reasons are always going to be general. So when we give a reason, we're just giving general definitions, theorems, or postulates. Okay, so little brief logic lesson. Let's go ahead back here and look at this. So we want to write a two-column proof, and in the proof we're given that the measure of angle 1 is equal to the measure of angle 3. So we see here that angle 1 and angle 3 are equal, and we're trying to prove that the measure of AEC, which would be this angle right here, is equal to the measure of DEB. Okay, now you'll notice that what's different about those two things is this angle in between, angle 2. And so if we add angle 2 to both of those, we're going to end up with the thing that we're trying to prove. So if we start off here, we say we've got the measure of angle 1 equal to the measure of angle 3. That's given to us. Okay. Now our next statement is the measure of angle 2 equals the measure of angle 2. The reason, you'll remember, reflexive property. Think about reflexive property. Looking in the mirror, you see the exact same thing. Okay, now as we move down here, what are we going to do with statement 1 and statement 2? Well, we're going to add them together. And so that's the addition property of equality. We're adding step 1 and step 2 together, and you'll remember that from what we did in our last lesson, the addition property of equality. Now, what do we know about those two angles? Well, the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC, and the measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. That's the angle addition postulate. The two smaller angles add together to be the whole angle. And now, what have we done here? Well, let's look here and just kind of highlight it for you. Here's angle 1 and angle 2. It's up there. Okay, I should do that in yellow because I drew it in yellow on my diagram. So let me change that. So 1 and 2, that's our yellow one. 3 and 2, all right, and we're just substituting in what we have for those. So that's the substitution property, and we've proven. So one thing to note here is the prove is always going to be our last statement. So once we get to the thing we're trying to prove, we don't need to go any further. So we're trying to figure out how do we get from what we're given to what we're trying to prove. And we have that there in the first example. Okay, let's look now at this one. Write a 2-column proof. Given AB equals CD. So I just put some dots on there. On your paper it doesn't have those. We want to prove that, let's use some highlighter here. We want to prove that AC, so that would be this segment there, is equal to BD. Well, you're probably going to notice that, well, if we just add BC to both of those two would be there. And sometimes I like to think about it with numbers. Like if AB was 5 and BC was 8, well, what would we do? 5 plus 8 would be 13. 5 plus 8 would be 13. Okay, those two would be equal. So let's see how we can go about proving that. All right, well, we're going to start with what we're given, not surprisingly. AB equals CD is given. Okay, BC equals BC. That's the reflexive property. All right, looking in the mirror. Now, what are we going to do to those two things? Well, we're going to add them. AB plus BC equals CD plus BC. That's the addition property of equality. And we did that here with steps 1 and 2. We're just adding those two things together. All right, now we're going to do the segment addition postulate. So AB plus BC equals AC. All right, let's just highlight this. So AB plus BC, whoops, got the green one again, I need the yellow one. AB plus BC, that's our yellow one, equals what? AC. CD plus BC equals BD. There's our segment addition postulate. So we're going to go ahead and we're just going to put those in there using the substitution property. So BD is our green one, AC is our yellow one. All right. Now, again, look at our last statement. Prove is our last statement. So we have accomplished that proof there for that particular question. Okay, let's go on to the next one. We talked about that already here. Let me pull my screen up so we can talk through it. All right, now we're given ABD. Now we're giving the larger angle here, ABD, equals the measure of CBE, which I've highlighted here in green, and we're trying to go from kind of a large down to a smaller pair of angles. And you'll notice before, on the last two, what did we do? We added, and in this case, we're going to subtract angle 2. So it's going to follow a very similar pattern. except for instead of adding, we're going to subtract. So we've got the measure of angle ABD equals the measure of angle CBE. Okay, now what do we have here? Let's do our angle addition postulate. Measure of angle 1 plus the measure of angle 2 equals the measure of angle ABD. Measure of angle 2 plus the measure of angle 3 equals measure of angle CBE. Okay, again, let me just highlight to help you connect that with there. So ABD, that's our yellow one. And this is our green one. All right, now the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. That's simply our substitution property. Okay. Measure of angle 2 equals the measure of angle 2. Reflexive property. And then we're going to subtract. So when we subtract 2 from each side, what happens? Well, they kind of cancel each other out. You probably don't want to draw that on yours, but I just want to show you what's happening. And we're left with the measure of angle 1 equals the measure of angle 3. Subtraction property of equality. We're subtracting steps 3 and 4. So step 4 from step 3 gives us that final result that we have there. All right. So in the first two, we went from small to large. We did addition. In this one, we had a bigger angle and we went to a smaller angle, and that was subtraction. And down here, we're probably going to have the same type of thing. So let me put some dots on here. So let's do call that A, B, C, and D. So given AC, let me get my highlighter back. Okay, given AC is equal to BD, all right, we want to prove that AB equals CD. So again, we're going here from large to small. So we're going to probably use subtraction property of equality. So AC equals BD, that was given to us. All right, now AB plus BC equals AC. So let me highlight that. There's our, gotta get my yellow. Yellow. And then the other one is what we've done with green. Can you think of the reason for that? If you said to yourself, the segment addition postulate, you are correct. This is the segment addition postulate. Okay. Now, what are we going to do? Well, we're going to now substitute. Substitution property. Okay. BC equals BC. We're looking in the mirror. That's the reflexive property. Reflexive property. All right, then how are we going to get there? Well, if we subtract BC, so again, if we subtract BC minus BC, those cancel each other out, and we're left with AB equals CD. So this would be the subtraction property of equality. All right. All right, and there you have it. We've got 4 examples. The first 2 are addition. These 2 are subtraction. And you have an assignment that is going to give you some more practice with this. So feel free to use these notes here, ask lots of questions, and we'll keep things rolling. Thanks for listening and tuning in.